The agent that turns red may not have caused the failure. A bad decision can move through several components before one finally exposes the damage. I'm Mehrdad. Let's trace the real cause, instead of blaming the place where the symptom became visible. A trace tells us what ran and where execution stopped. It does not assign responsibility. A useful diagnosis asks 4 questions. Which contract governed the component? Which consumed dependency reached the failed check? Who had both a duty and a realistic opportunity to recover? Finally, does a controlled change alter the outcome? Contracts, dependencies, recoverability, and intervention turn an execution record into a testable investigation. Consider a travel planning workflow that must produce a Monday arrival with a feasible airport connection. The planner sets the arrival, budget, visa, and connection constraints. A support agent retrieves airport transfer and minimum connection information. A task agent assembles the route, and a verifier checks every hard constraint before release. The final itinerary allows only 45 minutes for a transfer that cannot be completed in that time. 4 explanations fit the visible result. The support data may be stale. The planner may have omitted the constraint. The task agent may have ignored valid data. Or the verifier may have missed a defect it had enough information to catch. One outcome score cannot separate those responsibilities. If this kind of production diagnosis is useful, like the video and subscribe for the rest of the multi-agent evaluation series. Start by making each component's obligation explicit. Record the inputs it must receive, the transformation it owns, the output it must produce, and the checks it must run. A coordinator might preserve request constraints. A tool component might return sourced, versioned records. A worker might be required to use supplied context, while a reviewer tests output invariants. These are engineering examples, not a universal role taxonomy. The rule is broader. Evaluate a component against its declared contract, not one aggregate accuracy score. Ask whether the required input arrived, which exact record was consumed, whether the promised transformation occurred, and whether the required check ran. Those questions make a suspected violation falsifiable. Next, preserve execution as more than a time-stamped list. Give component calls, tool executions, validations, retries, and recovery attempts their own spans or equivalent records. Store stable identifiers, build and policy versions, input references, output references, and check results. Parent-child edges describe nested execution. Explicit dependency links describe which records a later decision actually used. That distinction matters because the next event in time is not necessarily the source of the next decision. A linked graph can connect a failed check to its exact input, then to the output and operation that produced it. This structure creates causal hypotheses. It does not prove them. Keep sensitive content redacted, or retain controlled references instead of copying unrestricted payloads into telemetry. Define the failure as a concrete, violated invariant before selecting a suspect. Start at the failed check and move backward only through records it actually consumed. This is a backward slice. Follow the failed output to its exact input references, then to the operations and records that produce them. Slow spans, retries, metric spikes, and unusual messages outside that slice may still matter, but they are only correlated until evidence connects them. The slice narrows the search without declaring a cause. It also exposes instrumentation gaps. If the system never recorded which input version reached a decision, mark that branch unresolved. Timestamp proximity is not a safe substitute for a missing dependency. The earliest defect on the consumed path is not automatically the decisive failure. Responsibility depends on both contract and recoverability. Mark an originating defect when a component introduces invalid state. Mark propagation when a later component consumes that state but has no duty or practical ability to reject it. Then inspect every review or recovery point. If its contract required the relevant check and the necessary information was available, accepting the state is a missed recovery. Change the contract, and the attribution may change. A midstream component can own both propagation and missed recovery when it was required to stop the defect. If no downstream component could detect the problem, the origin carries more weight. The most visible failure may therefore be a downstream symptom, but that remains a hypothesis. Report origin, propagation, and missed recovery separately instead of forcing one culprit. Chronology is useful for navigation, not proof. The earliest odd span may be harmless setup. The loudest failure may be where invalid state finally becomes visible. The largest anomaly may sit outside the consumed path. Parent-child structure shows execution organization, not automatic causal responsibility. A comparable healthy run can strengthen a hypothesis by exposing a changed record, policy, dependency edge, check result, or recovery path. That is contrast-supported evidence. It tells us what differs between runs, but not whether that difference caused the failure. To answer that stronger question, we need to intervene rather than only observe. Restore a software snapshot from before the suspected operation. Hold the request, model, prompt, policy, seed strategy, dependencies, and downstream configuration as stable as the system allows. Change one candidate field, such as a timeout value, then replay the dependent operations and checks. Repeat the test enough times to expose non-deterministic outcomes. If that single change repeatedly repairs the invariant, the candidate gains intervention-supported evidence within this replay model. If the failure remains, the result weakens that hypothesis and redirects the search toward another component or an interaction. This is stronger than chronology because we changed one variable and observed the downstream effect. It is still conditional. Incomplete snapshots, hidden external changes, inaccurate dependency links, stochastic models, and interacting defects can mislead the replay. Emerging work, such as causal flow studies, intervention-based attribution, mainly in sequential single-agent traces, extending the idea to general multi-agent graphs requires careful replay fidelity. Report what changed, what stayed fixed, how many replays ran, and which assumptions limit the conclusion. Build diagnostic requirements into the harness before an incident. Every relevant record needs a component identifier, contract identifier, build version, exact input references, one output reference, dependency links, check results, and a replay snapshot or checkpoint reference. Preserve the model and policy versions, tool choices, retry behavior, and validation outcomes when they can change execution. Use explicit record links instead of reconstructing dependencies from timestamps. Protect these fields with redaction, scoped access, and retention limits. Sensitive content should remain behind controlled references when unrestricted capture would create risk. This instrumentation connects a suspect input to a failed check, shows whether recovery was possible, and makes a controlled replay reproducible. Attribution should communicate evidence strength, not manufacture certainty. Observed means the trace shows a contract violation on a consumed dependency path. Contrast supported means comparable healthy runs reveal a consistent difference. Intervention supported means a controlled replacement repeatedly changes the outcome under stated replay assumptions. Unresolved is the correct label when state is missing, replays disagree, or several causes interact. Report these layers with the supporting records and limitations instead of issuing one blame score. Current automated methods can struggle to identify the decisive step even when conversation logs are available. The who and when benchmark makes that limitation concrete. Automated attribution can rank debugging hypotheses and surface relevant evidence. It is not a verdict, and it should not silently assign operational or human accountability. The visible failure is the starting point, not the verdict. First, define the broken invariant and follow only the records it consumed. Second, use contracts and recoverability to separate origin, propagation, and missed recovery. Third, replay one controlled change and report the resulting evidence strength. That is how a red node becomes a testable diagnosis. If this video was useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. I'll keep publishing evidence-backed work on agentic systems. In video 4, we'll decide which evaluation signals need rules, statistical baselines, or an LLM judge. I'll see you in the next one.